Welcome to this video lecture on the subject optical and microwave engineering. So in this lecture we are going to discuss about directional couplers. So a directional coupler is a microwave passive device which has four ports. So it is used for coupling a known fraction of power. So generally it is used in power measurements. So it couples a power into auxiliary line while the power is flowing from the primary waveguide from input to output port as shown in this diagram. The remaining port is ideally isolated port and matched terminated. So it can be designed to measure the incident power, reflected power and standing wave ratio. So in this diagram we can see the coupling device, so which has four ports. So 1 and 2 acts as a primary waveguide, 3 and 4 acts as a secondary waveguide, where the main power flows from the port 1 to port 2 and the part of the power can be taken for the measurement purpose, and it couples the power to port 4. So port 3 is an isolated port. So these are the properties of directional coupler. So a portion of power traveling from port 1 to port 2 is coupled to port 4, but it is not given to port 3. Similarly, it acts in reverse. From port 2 to port 1 is coupled to port 3, but it is not given to port 4. So there is one input port, one received port, and also one coupled power and one is back power. Performance characteristics of a directional coupler. There are three main performance parameters: coupling factor, directivity and isolation. So coupling factor of a directional coupler is defined as the ratio of incident power to the forward power. So it is usually measured in decibels. So it is given by 10 log of P1 by P4 or Pi divided by Pf. Next parameter is directivity. The directivity of a directional coupler is defined as the ratio of forward power to backward power. It is expressed in decibels by 10 log of P4 by P3, and isolation is defined as the ratio of incident power to back power. So it is measured in decibels, 10 log P1 by P3. So these are the three performance parameters of a directional coupler. So let's see one of the example for a directional coupler. Two-hole directional coupler. It consists of two waveguides, primary and secondary, with tiny holes in between them. So these two holes are at a distance of lambda g by 4, where lambda g means it is guide wavelength. So it is given in this diagram, primary waveguide, and it is separated by two tiny holes, and we have a secondary waveguide. So the length between the two holes is 2n plus 1 lambda g by 4. So it is multiples of lambda g by 4. So fraction of the wave energy entered into port 1 passes through the holes and radiated into the secondary guide, as the holes acts as the slot antennas. The forward waves in the secondary guide are in same phase regardless of the hole space and are added at port 4. The backward waves in the secondary guide are out of phase by 180 at the position of the first hole and are cancelled at port 3. So we can obtain the scattering parameters and scattering matrix of a directional coupler, which are used for high frequency parameter measurement. So directional coupler is a 4-port network. So using the property of S matrix, we can obtain 4 cross 4 matrix as from S11 to S44, which has 4 rows and 4 columns. And by applying the property of S matrix, the diagonal elements are 0 for a perfectly matched network. So the diagonal S11, S22, S33 and S44 equal to 0. And next we are applying the symmetric property. So symmetric property, we apply Sij equal to Sji. So for each and every term, the transpose of the matrices can be equated, and a symmetry property is written as S12 equal to S21, and similarly for other parameters. So and also another property of directional coupler is there is no coupling between port 1 and port 3. So these two parameters should be 0. So S13, S31 equal to 0. And similarly for port 2 and 4 there is no coupling. So S24 and S42 equal to 0. So by applying all these conditions, the S parameter is written as this matrix where the property is applied. And by applying the unity property of S matrix, we can multiply the S matrix by complex conjugate where we equal to unity matrix, and we need to solve the three set of equations R1C1, R2C2 and R3C3. So we get S matrix as 0P, 0JQ and similar to that. So here P is the transmission factor, Q is the reflection factor. So let's take the assessment questions. Power dividers and couplers are dash microwave components used for power division or power combining. So passive, active, linear, non-linear, these are the options. So power divider and couplers are basically passive devices where the power dividers are used. So do not store any energy, they are called passive microwave components. So the answer is A. And isolation of a directional coupler is measure of power delivered to the uncoupled port. So the answer is A. Thank you for listening this lecture.